So now let's just put all of these pieces together. We want to have a sketch of our quadratic function, and we can get a really decent sketch by having these pieces, the intercepts, the vertex, knowing whether it's opening up or down. That can give us a good graph. So what you can see is with this example here, our function is in vertex form. So something we can do is look at A, so we can make a note that this function is going to be opening downward. Then we can see our vertex right away. So because I see that x minus 6, the x coordinate's going to be positive 6. And then with the plus 4, we'll have a positive 4 for y. Next I'm going to go to the y-intercept, just because that's a fairly quick one. So with the y-intercept, we're looking at f of 0. So we're looking at negative 1/2 times 0 minus 6 squared plus 4. So it's going to be a negative 1/2. So negative 6 squared is 36. So let's see, a half of 36 is 18. So negative 18 plus 4. So that's giving us a negative 14. So I have this coordinate 0, negative 14. Now let's go for the x-intercepts. So we're plugging in 0 for f of x. So we're going to have 0 equals negative 1/2 x minus 6 squared plus 4. So this is something I mentioned in the last video pretty quickly when we were looking at the vertex form. So we'll end up using the square root method here. So what I'm going to do is I'm going to move some things around, but my goal is essentially to get this x minus 6 squared all alone on one side of the equation, because then we can just take the square root of both sides. Now, you could FOIL out the x minus 6 and simplify it and basically get it to our standard form, but then get to that standard form and then you would need to factor it or use the quadratic formula, so it would just be a lot more steps. You would get to the same answers in the end, but I always think of like the more steps you add in, the higher the chance of making a little error, so minimizing the steps can be a good thing. Alright, so first thing I'm going to do is move that plus 4. So I'm going to subtract 4 from both sides. So 0 minus 4 is negative 4 equals negative 1/2 times x minus 6 squared. Alright, so I want to get rid of that negative 1/2. And there's two ways you can think about this. You could do our standard like divide by negative 1/2, and that works great. Divide by negative 1/2. In terms of simplification, like say we were trying to do this without a calculator, that can be a bit, like division with fractions can be hard to understand. So what we could do instead is think of multiplying. And multiplying by, we want to multiply by a negative so that it turns positive. And then it's the idea to create a 1 right there, I need to multiply by 2. So you can use the denominator to help out, or really it's this idea of using the reciprocal of the fraction, the idea of flipping the numerator and denominator, and that would give us a 2 over 1. So if we take negative 2 times negative 1/2, that all turns to positive 1. And whatever we do to one side of the equation, we have to do to the other. So this will give us a positive 8 equals, and now we have our x minus 6 squared. So now we can take the square root of both sides of the equation. So we'll have the square root of 8, or really this plus or minus square root of 8 equals, and then with the square root and the square, they cancel each other out. So we'll just have x minus 6, and then we're going to add 6 to both sides. So we get x equals 6 plus or minus square root of 8, or if you want to simplify that radical, that's a 2 square root of 2, because you have a square root of 4 times square root of 2, and the square root of 4 simplifies to 2. Now, in terms of graphing, to plot the point 6 plus 2 root 2, I don't know where that lands. So we're going to grab some decimals. So what I'm going to do is separate into the two cases here. I'm going to look at x equals 6 plus 2 root 2 and 6 minus 2 root 2. Just to get some decimal approximations. So we're going to go to our calculator, and we're going to take 6 6 plus 2 root 2. So we have an 8 point, go to 2 decimal places here. How about that? 8.83. And then we want to do the same thing but with subtraction. So we can just edit that in the calculator here. So instead of addition, subtraction for a 3.17. And now we have these points that we can plot. So let's go ahead and graph this. Just to make a note too about plugging into MyOpenMath. When you graph parabolas in MyOpenMath, it wants the vertex first. So what I'll do is I'll graph this kind of like how you would in MyOpenMath. So the first point we're going to plot is the vertex, so 6, 4. So I'll go 1, 2, 3, 4, 5, 6, 1, 2, 3, 4. So if I was in our online homework on the lecture and making a graph, I would plot that point first after selecting the quadratic function. And then we need a second coordinate. Now, if you have the y-intercept, that can be nice and easy, but this is a case that can come up where our y-intercept is actually off the page here. Our grid here is actually going to -12, so our y-intercept is off the page down there. So I can kind of visualize where it's landing, but I'm not going to use that point. But this is where it's nice to have the x-intercepts. So we have a 3.17, and when you're in MyOpenMath, it kind of locks, like either at a whole number or middle a whole number, and just choose the one that's closest. So like 3.17, you could graph pretty close to 3. Since we're doing this by hand, I can kind of estimate it a little bit more. But if you're in the online homework system, like basically graphing 3, it would allow that kind of error coming through. And 8.83 is basically 9, but 3, 6, 9, but a little bit less. So about right there. And with that, we can get a general shape for our parabola going. And we just draw the rest the best we can. So, with that, a little tip with MyOpenMath in there, with first the vertex, then a second coordinate. If your y-intercept is off the page, then use an x-intercept. Alright. Forming the equation of our function given a graph. So you can use the vertex form or the factored form. The factored form is great if you know the x-intercepts. As we can see here, the x-intercepts for this graph are kind of messy, so I'm going to look at the vertex and see, ooh, that's at a nice clear point there. So we're going to use that vertex of 1, positive 7. Now, our vertex form, as a refresher, goes ax minus h squared plus k. Now, to know what a is a little tricky with these functions. When we learn in your next class, in the next algebra class, we talk about graph transformations. We're not going to talk about it very much in this class, but maybe you've seen graph transformations, so maybe you can find a just by looking at the graph. But what we're going to do for our class is assume we don't know graph transformations. And with that, we're going to keep a as an unknown, but we'll plug in our vertex. So what that will look like for this case is I'll have f of x equals, I'm going to keep a in there as an unknown, and then we'll have x. So the x-coordinate's positive 1, so we'll have minus 1, and then squared, and then positive 7, so plus 7. Now, we can't just leave a like that because there is a number for a, and how we can solve for it is by grabbing another coordinate. So you can use absolutely any coordinate that shows up on this graph. Where I typically start is with the y-intercept because plugging 0 into things is typically very nice. So with that, I'm going to look at our y-intercept, and our y-intercept is a nice coordinate of 0, 6. So I'm going to plug in 0, 6 here. So I'm going to have 6 for the output, a times 0 for x, and then plus 7 on the outside. And then we're just going to solve for a. So 6 equals a times, so negative 1 squared, which is positive 1. So I just have a right there, and then plus 7. And then we'll subtract 7 from both sides. So a is negative 1. So our function, now we can put it all together, is a is negative 1. So we'll have this negative x minus 1 squared plus 7. And then a good thing to do is just make sure that the value for a makes sense. Like negative, okay, is it opening downward? Yes, so that matches up. And then 1, again, is more in terms of graph transformations. So we won't worry too much about the numerical value, but just positive versus negative is a quick check that we can do. All right, let's do the same thing for this one. So again, if I want to use the factored form, I'd look at the x-intercepts, but those are a little messy here, so I'm going to focus on the vertex. So the vertex is negative 4, negative 6, and we'll need another coordinate, and I'm going to look for that y-intercept again of 0, 2. Again, if you can't see the y-intercept on the graph, you can use any coordinate. Like we could use this coordinate 1, 6, and that would work great. We could use this coordinate negative 2, negative 4, and that would work great too. Okay, so I'm going to plug in the vertex. So f of x equals, we don't know what a is. I have an idea that a should be positive, but I don't know numerically what it is. X, and then let's see, the x coordinate's negative 4, so this will be a plus 4 squared. And then minus 6. Now we're going to plug in the coordinate 0, 2, so we have an output of 2 when x is 0. And then we're going to solve for a. So 2 equals a times 0 plus 4 is 4, squared is 16, minus 6. I'm going to add 6 to both sides, so we'll get 8 equals 16a. And then we'll divide both sides by 16. So a is 8 over 16, which simplified down is 1/2. So our function is positive 1/2 x plus 4 squared minus 6. And if you get to the end here and you're like, I'm just not sure if that's right, you can go to our graphing calculator. So if we go to the Desmos graphing calculator and plug in the function we just found, so you go y equals 1/2 x plus 4 squared, and then minus 6. And then you could just check some coordinates and see that it does match up. There's our negative 4, 6, there's our 0, 2, there's kind of our weird x-intercepts if we wanted to check those too. So if you're in doubt, plug it into the graphing calculator and see that the graph matches up.